I'm in Istanbul, capital of 3 ancient empires, where an engineering dream is becoming a reality.
Wow.
A rail tunnel connecting 2 continents, Asia and Europe, built over 180 feet underwater. But getting down there means surviving terrifying currents, crushing pressure, killer quakes, and a haunted past.
Oh.
Do I at least get like a knife or something?
My name is Danny Forster. I learned a lot about engineering in architecture school. But after graduation, I thought it was time to get my hands dirty. So I went looking for tough work. Some things you just can't learn from a book. I'm not sure I knew what I was in for. But I think I'm up for it. Today, I am gonna dive 20 feet below this murky, creature-infested water.
You know, sometimes when you say you can do something, and they're like, "Oh, can you dive?" And you say, "Yeah, totally. I can scuba dive." And you're referring to a resort course you did in the Cayman Islands about 15 years ago with your dad.
Now, this is a first for me. An underwater construction site. Let me explain what I'm doing here.
I am in Istanbul, the only city in the world that straddles 2 continents, Asia and Europe.
Separated by the Bosporus Strait.
Each and every day, millions of residents commute from one continent to the next. There are 2 ways to do it. You got a bridge, or you got this, a ferry.
Turning this city into traffic madness.
Okay.
Turkey's solution? An underwater rail tunnel between the continents. It's what's known as an immersed tunnel, where tunnel sections called elements, each as big as a 40-story building, are built on land, towed out, sunk, and attached like Legos on the sea floor. 11 elements in all. Now that's difficult enough, but here's the rub. This is one of the most treacherous job sites on the planet, the Bosporus Strait, a notorious ship graveyard with a deadly past that's come back to haunt them. I'm here building one of their massive tunnel elements. To find out how engineers plan to conquer these waters, and to find a way down to the seafloor, becoming one of the first people to walk on the bottom of the Bosporus.
Gross. Gross.
As an architect, I've never been on a project where the exterior form mattered less. A concrete box that's pure function. An engineer's dream assignment.
Good morning.
Good morning.
I'm Danny.
I'm Steen.
Steen, nice to meet you. So we're heading out to see the next element that's going to be submerged?
Yes, we have one element down on the bottom already now, but we are planning to have the next element down in the near future.
With some of the biggest immersed tunnels under his belt, Steen is like the Yoda of aquatic engineering.
Typically, on construction sites I've been on, they pick a site, they build a fence, and they have their small controlled area. Your construction site is in the middle of the Bosporus Strait.
Working in the Bosporus is, of course, the biggest challenge we have here, because water is unpredictable. You have to respect nature. Water is a friend. If it works together with you, it becomes an enemy if something goes wrong. We try to always have the water as a friend.
That's it, the immersion pontoon. A 300-foot-long element-lowering machine. Hanging under it, the tunnel element.
Welcome on board.
Thank you. Nice to meet you.
I see you're not properly dressed. You better take this life jacket.
Thank you. Thank you.
The big piece of concrete in front of us, it's element number 10.
So what looks to me like a floating slab is actually 8.5 meters deep.
Yeah, it's actually a floating concrete box with a steel shield around it to make it waterproof. The element is completed. That means it's all closed concrete.
So thing is a sealed tube, right? Concrete, totally sealed, watertight, bulkheads on both ends. The only way down is through that.
It's like climbing into a well.
I have tried it many times. You can just follow me.
Should we make a wish before we go into the well?
Okay, no problem. So what are you wishing? To get safe back?
I was hoping to come back out of this thing. Klaus!
Are you coming?
Are you okay?
I'm okay. It's dry and safe.
All right.
I'll wait for you.
Oh, boy. Let's just be clear right now. Above a 25-foot hole, water. Weirdest thing I've done. Going to a rail tunnel. Floating in the ocean.
So welcome. Welcome to our second tunnel element.
Wow. So now I'm inside a concrete tube 8 meters under the water.
Correct.
Just to be clear, I'm down here. And although it's hard to believe, in a few years, trains will run in both directions. One to Asia, one to Europe.
There's water on that side of that concrete.
Believe me, you saw it just before.
That bulkhead wall right there, that's keeping water from coming in and killing us.
That must be 100% watertight. With the deepest element, we are going down to 60 meters of water, so you really rely on these.
On the surface, 1 atmosphere of pressure pushes on the element. As it sinks, it's squeezed by 1 additional atmosphere every 33 feet. The deepest tunnel element will be subjected to 6 atmospheres of pressure, a tremendous force that squeezes in from every direction. If not built perfectly, the tunnel could implode, crushing trains filled with passengers. Constructing an indestructible underwater tunnel begins here, 20 miles south of the city at the Tuzla shipyard.
I'm standing inside what will soon be one of the 11 tube sections of the Marmaray Tunnel. Each piece is over 20 feet tall and 400 feet long.
With 1 element moving into position and 1 sunk, they have just over a year to build the final 9 sections of their new rail tunnel.
Once this immersion tube element is complete, it's gonna get pushed out into the water, then submerged 180 feet. Now, the only thing that's gonna keep all this water from rushing in and killing the workers is that thing right there. This bulkhead door is gonna seal each side of the chamber and make it safe for guys to work and install the piece. Right now, they're using come-alongs to bring the piece in and close up the face. I'm literally pulling this bulkhead closer. Okay, good. So right now, the bulkhead is completely flush on the bottom edge right now. It's tilting out on the top edge. There's 1 piece of metal obstructing it. So this guy's climbing up with the acetylene torch. He's gonna cut that little white piece of metal off, and then with it gone, it should slide right into place and create a nice watertight seal.
Something about this doesn't look safe.
Oh. So that little metal piece that was in the way before was actually not in the way so much as it was holding the piece up. And when you burned it off, the entire bulkhead door it was like it was gonna come down on me like in a cartoon. That was scary.
Thanks to the crash, the bottom is now out of alignment.
This corner right here, pretty simply, needs to go right there. And it can't be a little off because that seal has to be so watertight that when this thing is over 150 feet under the seawater, nothing gets in. They just about got it. I have to learn the word for pull more in Turkish. Done.
Okay.
You did it. Well, that's it. Thanks to all of their work and my 7 pulls, this bulkhead door is in place. Final step, weld it nice and tight and get a water seal joint all the way around.
The Bosporus Strait is full of deadly surprises. Straddling one of the most active fault zones on the planet, it's been over 100 years since the city took a direct hit from a quake, and scientists say they are long overdue. A a big quake could liquefy the sea floor, collapsing a nearly mile-long tunnel tube. So engineers came up with a bend but don't break strategy, adding flexibility with specially designed seismic joints that allow the entire tunnel to move, and stability by grouting beneath the tunnel, burying it in a trench, and reinforcing the elements.
So this is where the process really begins. They create a tube 135 meters long of steel. Okay. Step number one, get a big L-shaped piece of rebar, get it in place. Number two, lock it. 3, 4. Oh, there it is. Number 3, get more rebar, right? Okay. 2, 3. Rachel speaks. He's Russian, not Turkish. Russian worker here. Nicely done. Oh yeah, of course. Gotta knock one out. Gotta knock one out, man. Uh-oh. No good? No, but Rachep's not happy. Rachep comes in with his unbelievably smooth moves. Goes with a single twist, comes up with a triple twist on the back end. Locked it. Look at that. Over 1,000 tons of this rebar is used to build just one tube section. Now, keep in mind, what he's doing right now is basically building almost like a bird's nest of rebar, coming down the vertical wall, across in the bottom of this thing. When they're all done with this, then comes the concrete.
In total, the element is fortified with over 18,000 tons of concrete and steel.
Recep, спасибо? Thank you.
Now, it may not look pretty, but this tunnel is designed to withstand quakes up to 7.5 on the Richter scale. On this job, I'm starting to see how beauty is actually more than skin deep. Exhibit A, the Tuzla Shipyard. At first glance, a quagmire of concrete and steel tunnel parts. Actually, an innovative immersed tunnel assembly plant. First, the bottom half of the element is erected, and the concrete cast. Then, they're moved to the second station, where the top half is poured. Finally, it's towed out to the pontoon so it can be sunk, cranking out up to 4 18,000-ton elements every year, theoretically enabling engineers to stick to their tight deadline. The element I've been working on is ready for the next station. The challenge is, there is not a crane in the world that can lift it.
So then, how do you move this thing? Well, you take a gigantic bathtub, fill it up with water, and then simply float the piece out.
Flooding the dry dock starts by opening 3 valves.
So who will be down in the yellow scaffolding, opening the flange? You're gonna be down there? Basically, you're gonna be taking off the bolts, opening the valve, and then water comes. So can I be down there with him?
Yes,
in the flange?
you can be.
Will I be getting a little, because he's got a wetsuit on. Will I need a wetsuit? Because this is...
So, but I have one wear.
Only one. That's nice, that's great. He's only got one.
Apparently, when we open the valves, water will bust out like a giant fire hose. So my cameraman has been ordered to stay back. But somehow it's safe enough for me and my camera.
Yeah, that's stuck. That's not moving. Did it move? Anything? No?
Okay, brute strength is not working. We'll just cut him off.
So we're cutting him, huh? We can't get him off? We have to cut... What? Oh, don't do that. Oh, that's bad. Yeah, look at that. It's off. We got one off. Nice. Oh! He's basically just killing the bolt. So for the last bolt, what happens now? Water will come.
Water's coming out already. The water is boiling.
Can you imagine how much pressure is behind this wall, pushing on it, trying to get through? Oh my God! Whoa, 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 whoa! We got water! We got water!
Not exactly the Niagara Falls they were warning me about.
The second valve's about to come off. Oh, look, it's coming off. Bang! We got 2 down. Marmara AC is coming in. We're flooding this thing. This is the last one. We've got 2 of them down. The third one is just about done. There is simply 1 bolt holding it on. Knock this last bolt out, and that's it. Here it comes. There it is. There it is. There it is. Well done. No, it's okay. Nicely done. At a rate of 250 cubic meters per hour, the water is flowing. And in 36 hours' time, this entire dry dock will be full of 8,000 cubic meters of water. And these 2 tunnel sections are going to be floating up and out the door. Now, if you want to see both before and after pictures of this tunnel, we got it all on our website at discovery.com/builditbigger. I put them all up there myself.
Istanbul was once the capital of 3 ancient empires, and for good reason. The Bosporus Strait has long been a major trading route between Asia and Europe. Over 40,000 massive ships still cruise through here annually. Not exactly the ideal place for immersed tunnel construction. Adding to the difficulty, ferries.
Each and every year, there are over 300,000 ferry rides that cross both continents, and it's absolute madness.
Until commuters can be whisked through the rail tunnel, the 20-minute ferry ride is one of the fastest ways across the Bosporus.
We got the cars all loaded up. We're hanging out in Asia. It's time to go to Europe. That all happens because my man, the captain. What's it like navigating a ferry in this incredibly busy body of water?
Görmüş olduğunuz gibi burası çok dar bir alan. Bu dar alanın içerisindeki bu yoğun trafik mayın tarlası gibi bir yer.
Can you give me a lesson on how to actually drive a ferry in this amazing amount of traffic? Okay, I got a cruise ship to my port. I got a little ferry to my starboard. I got 3 other fishermen to my starboard. Got a tanker on the far starboard. All right, Captain. Whoa, hard left. Are you okay? Okay, so we just actually stopped and pulled a hard left because we're now in, oh, check it out, we're in the traffic lane. We've gotten into the center of the Bosporus Strait, meaning we've come to a full stop right now. And we're letting this big oil tanker cross in front of us. Basically, rules of the road, bigger goes first. I mean, this is kind of like Frogger, that video game. I'm in a small ferry trying to cross the Bosporus Strait, and you got big tankers coming left and right. It is really like 0-0. I mean, it's really like boat bumper cars out here.
When engineers attempt to sink their tunnel tubes, they halt all big ship traffic for nearly 24 hours. Incredibly, ship traffic from a millennia ago is causing them bigger problems.
On the surface, Istanbul is a cosmopolitan city of 12 million residents. But beneath me lies an entire underworld of Roman and Byzantine history, which is incredible if you're an archaeologist or a tourist. But for engineers trying to build a tunnel to go from Europe to Asia, it is an absolute nightmare.
Because to link trains to their record-setting immersed tunnel, huge tunnel boring machines must dig under the city.
Their job, it's basically like an arrow that nails a bullseye to get their TBM to hit right in the immersed tunnel hole.
On the Asia side, 2 TBMs dig around the clock. But on the European side,
Work has come to a screeching halt because of something they discovered in the soil. What was it? One of the most important archaeological sites in history.
they've literally run aground on an ancient harbor with thousands of priceless artifacts.
Not a single inch of tunnel will be bored by the TBMs until this entire archaeological site is completely recovered.
So how long is this going to take?
When it comes to the archaeologists, they say that no, time is timeless. We cannot give you time because we don't know what we are going to encounter. It changes according to the findings.
Their most amazing discovery? A graveyard of ancient ships, remnants of a killer Bosporus storm that wreaked devastation over 1,000 years ago.
I'm Danny.
Danny, nice to meet you. I'm Jamal Pulak.
Jamal, how are you?
I'm just fine, thank you.
This is a huge discovery.
Yes, it is a huge discovery, and since we have about 23 shipwrecks discovered so far and many more to come, this is the largest site that's been excavated for shipwrecks. And these are being found for the first time from the medieval period, from the Byzantine period. Ever.
So can you show me some of what you're doing? I mean, what does an ancient, 1,000-year-old ship look like that you found here in the soil?
You might not realize it, but this crater in front of us is a shipwreck.
That's a ship right here.
This is a shipwreck. That is the hull of a ship. You can see it's quite long.
Yeah.
This is a galley. That's probably going to be about 100 feet long, I would think.
Massive ship.
It is massive. It would have had at least somewhere between 20 to 25 rowers per side. So there'd be 50 rowers, 40 to 50 rowers for the entire vessel.
So this is where you have the guys in the seats and the guy walking around with the whipping them, saying stroke, and they pull.
Yes.
So what are we going to find in here?
Now, we're going to be going down to look at this 9th century shipwreck that we just started excavating.
Oh my, this is, wow, like a complete ship.
This is one of the best preserved ships that we have here.
This is a merchant ship from the late 9th century. Over 45 feet long, its round design allowed it to carry heavy loads, like stone, grain, and wine.
We have to be very careful with how we excavate, try not touch anything that can give us the slightest bit of information.
The wet earth has kept these ships from decomposing. But once they're exposed to heat and sun, they quickly wilt, losing valuable details forever. So the race is on to dismantle and preserve each and every piece.
And in fact, if we move down to the far end, we can see Sheila and Asaf getting ready to remove one of the pieces.
What we're about to do now is there's a frame down here.
This piece right here.
Yeah, and don't step on that, actually.
Okay, we're off to a great start.
Okay, well, won't do that. Yeah, I'll have to warn you about this.
Okay,
Yeah.
you want to move some wood?
Yeah.
So what do I do?
Squeeze in there on your knees. This is kind of yoga-like.
Yeah. Okay, so I'm here.
In the middle or on the end?
This is the one, that's the crack we're worried about.
So we gotta keep that together.
Yeah, I'm going to hold this, be pushing it together. Okay, now raise it up. Straight up. Slowly, slowly, slowly. Slowly. That's good. Not so fast. Okay, there we go. That's it. And Asaf, can you grab this so I can take my fingers out? Okay. Yeah, actually, I think I can. All right. You down?
I'm down.
Okay, good.
Okay, so we got one piece out successfully. We have about 2,000 more to go on this boat.
That's right.
And we have potentially as many as hundreds of more boats to discover. What are you thinking, 3 weeks we'll get back to tunnel boring or no?
As soon as we're finished, you can
soon as you're done.
bore away.
Bore away, yeah. So like in 3 months we'll be sorry. Yeah. No.
Yeah. Yeah.
Yeah, we're not gonna be done for a while, are we?
The process of ancient ship excavation takes up to 4 months per ship, including the final step.
So this is it, last step of the process. Once you got it, tagged it, named it, put it in place, got it wet, now we deliver it for permanent storage. Because the wood is so old and wet, it's lost all of its structural integrity. So if someone isn't holding one pinch point, it falls apart. Gotta have 2 hands at every single point.
Dinlenmek istediğiniz zaman söyleyin.
Hey guys, is this nearby? Where are we going? Like Poughkeepsie with this? Okay, right now, the last step, after delivering the piece of wood, it gets deposited in this water-holding tank with a chemical inside of it that'll permanently preserve the wood from any future decay. The story of that 1,000-year-old plank of wood, that's it. Found underneath a billion-dollar infrastructure train hub. Discovered, unmasked, tagged, and now put in this tank of water to be preserved forever.
With 23 ships already found and potentially more to come, the tunnel boring machines might have a long, long wait. Coming up, I go deep with the guys risking their lives to finish Istanbul's tunnel.
This is gonna be a nightmare.
Just outside of Istanbul, on the immersion pontoon, engineers are running a rigorous battery of performance tests on the next tunnel element. And right now, I'm inside inspecting the special equipment that actually controls the sinking.
And so that's it? That's the ballast tank?
That's a ballast tank. That's the heart of the whole immersion operation.
There are 5 tanks on each side for a total of 10.
Water comes through the pipe, into the valve, and then basically fills your 10 swimming pools.
That's right.
I mean, not to be crass, but you basically have 10 dumpsters.
Yeah.
Lined with rubber.
Exactly.
And you can control the amount of water in each of the 10 tanks, either putting in or taking out to the liter.
Correct.
By controlling exactly how much water goes into and out of every one of the 10 tanks, the element can be manipulated very precisely up or down.
The whole immersion is about controlling water. It be current in the surface, it be water inside the element in these ballast tanks. Bosporus is full of surprises.
It's all about the water. Basically, whatever the water says, you do.
Yes, that's right.
Amazing.
Up top, they're ready for a critical test.
As it stands right now, the element is held up about 10 centimeters by all 4 winches. In order to test the winches and make sure the element floats, they're going to drop it.
If you look over there, you see how actually the weight is taken by the heavy winches in these blocks over there.
So they're holding it up.
That's holding it up.
And in just a minute's time, they're going to release.
They're going to pay out wire.
If the test is successful, the element will float on its own just a few inches lower than it is now.
Number 2 is paying out.
It's really heavy, slowly, slowly.
But if the winches don't work, or the element starts to sink below the surface, they'll need to bring this entire unit back to the dry dock, costing time and big money.
Oh, look at that. So, Klaus, it worked.
It worked.
One test down, hundreds more to go.
Why is it so important to be testing everything out here in the staging area before you actually head into the Bosporus?
Because as soon as you are in the Bosporus, time is very limited. We know by experience that the current can change so fast. So you have to be dead sure that everything is simply functioning.
Lowering this massive concrete tube, longer than a football field, through strong surface currents will be difficult. But the job gets even more complicated 60 feet below, where another powerful torrent rages in the opposite direction. The 2 opposing currents could spin the element out of control. Their plan? Don't fight the water. Instead, work with it. The element is turned into the stronger surface current, like a ship's bow into the wind. Once it descends into the slower bottom layer, it's turned into precise alignment. If not for the ugly concrete exterior, I might call their plan elegant. A perfect mixture of engineering know-how and heavy construction. An elite team must also follow the elements through those gnarly currents. Armed with only a pair of flippers, the divers.
So I'm back at Tuzla at the shipyard, and it's been about a day and a half since they started flooding the dry dock, and I think they're ready to start diving. Dry dock is just about full. Both of these elements are now floating. The next challenge is to get them outside of the dry dock. How do you do it? Take this wall and remove it. The problem is the bolts located for this wall are down there.
Our job today, we will open the gate.
Now you're going to be cutting off a bolt?
Yes, we cutting off bolts.
This is all going to be underwater?
Yes, we can speak.
Welding underwater?
Welding underwater, cutting underwater. Everything is possible in under the water.
Possible, but potentially deadly. Industrial divers like Ali have one of the most dangerous jobs in the world.
Can I dive with you?
I mean, you can't dive with us, but maybe with a snorkel, you can. I wish you can watch us because visibility like 1 meter here.
So why can't I actually go down with you with the scuba gear?
Have you got a license?
Yeah.
Okay, this time is okay. You can come in with us. Yeah.
Are the jellyfish going to get me?
You need
face mask.
Face mask. I mean, you don't need, but you need carefully for it because if it's touch your face, it's not good. That's not good for you. I can tell you.
Have they ever gotten you in the face, the jellyfish?
Yeah, I mean, sometimes. Not really, but it's not. I saw this kind of one jellyfish the first time in Istanbul.
Yeah.
This red one.
Yeah, I saw that too.
Yeah, I haven't an idea about the red one.
You don't know about that one? Yeah. Could be lethal.
I saw first time here.
We're gonna go scuba diving, and we're gonna do welding and cutting underwater. I didn't even know that was like possible. Let alone safe. Oh, they're gearing up. They're getting ready to gear up.
All right, time to get geared up. There's no more stalling. We actually gotta go diving now. Let's go build a tunnel.
For safety, these guys use a full-face mask for air with an intercom system to the surface. My mask leaves me a little more exposed.
If something happens, if jellyfish touching your face, it is easy. You know, it's one lemon. You can put the lemon in your face.
Yeah.
It will be okay.
No problem.
No problem.
Nothing lethal.
Yeah. Don't worry.
All right, you ready? We're using just a regulator tied to a main set of commercial-sized tanks because we're going to be down there for substantial periods of time. With a regular tank, you got to come up every hour or so. But with this, I'm tied to them. Okay. And I can stay down there for as long as I want, or until the jellyfish get me. Just 1 second. Just taking a second. Once you go under, you can't see a single thing. I mean, it's like you can't see like a foot in front of you. It's like just a weird gray, murky black mess. I have no idea how someone's doing heavy construction, welding, no less, under there. Now this, when I was breathing, it felt like it was very hard to pull on the air.
The reason is it's coming from high pressure. Pipe is a little bit longer.
Yeah.
It's not like a normal scuba.
It doesn't feel like normal scuba.
No.
This is not normal scuba.
It's not normal scuba. It's not scuba.
Yeah.
You're now real diver now.
Not counting me, there are only 12 real divers on the entire tunnel project. There he is. Right now, he's slicing off some of the bolts holding together the 7 pieces of the dry dock gate. He's using a specially designed torch that flames up to 10,000 degrees, even underwater. He's protected by his rubber dry suit. My wetsuit, however, leaves me a bit more exposed, so I'm gonna stay a few feet away. These guys can work 160 feet underwater for hours, but it's time for me to get out of here.
It's really hard to breathe through these things. You're sucking air from, 40, 50 feet away from you, and so you really gotta pull and get it.
All the underwater welding is done. Pieces are complete. The crane is now attached. This is it. Here it comes. Here it comes. And now the dry dock is open to the sea. 15-ton piece up from the wall, hanging in the air. Check this out. We're picking it up and just putting it right over there. The last and final step is to remove these final 4 rear supports. So now we're getting in the boat. Do we want to pump out the boat or with the water, or are we okay with that? Here, I'll do it over here. That right there is the rigging spot. When the crane's ready, they're going to swing the cables over. We'll attach the rigging right there and take this piece up out of the water, put it to the side, and clear the way for the element. Like this? Yeah, okay. Is it going through? Okay, it's one side. All right. Rigging is set. Crane is now ready to go to lift this piece up and out of the water.
Now there is a guy who loves his job.
There it is. Check it out. You can see it's coming up. Now floating a bit, rocking back and forth, and there she is, coming up out of the water. I mean, it's huge. It's just huge. Look at it. I mean, this is a massive piece, halfway buried, 35 feet underwater, and there it is. Look at it. Just picked it up like it's nothing, put it to the side. 2 down, 2 more to go. Good? Take it up. We're ready to go. God, these things are huge. Coming in for the last piece. If you want to learn more about how to build an incredible underwater tunnel, check out our website, discovery.com/builditbigger.
The tunnel will carry 150,000 passengers an hour under the Bosphorus Strait.
Thanks to the able hands of some incredible elite divers, we were able to work underwater, welding and cutting, taking apart what is basically the largest garage door in history. And now this element is ready to go out to sea.
Okay, so today's a big day. I'm driving to Tuzla, which is the shipyard where they're building the elements, and after weeks of work, today, one of the elements is taking one step out of its home and heading out to the Marmaris Sea. Oh, look, they're getting the rigging set right now. Jeez, we actually gotta go, we gotta go.
The time is now to float the element out of the dry dock and into the next station where they can cast its concrete top. But for this 440-foot-long beast, months of their hard work must swing perilously close to the side.
Remember the last time you took your dog for the walk? Same sort of thing, except instead of a dog, you have an 18,000-ton tube element. Same difference, though. Put on the leash, put on the tugboat, go for a walk, baby. We are ready to go. Tugboat's got it? The rope is now taut, and they're pulling this thing. Those guys are riding an element. They are surfing on a 400-foot-long piece of steel. Look at that thing. Look at it. It's floating. Literally, it's floating. The thing is moving. So now that the piece is floating out of the dry dock, it needs an escort. We got about 5 different boats out here, all coordinating how to move this massive piece. And we're taking the lead. God, look at it. It's like the Death Star. It's so big. So there's the tugboat right there. That is what's pulling that entire piece.
Months in the making, this element will be topped off, dragged out, and submerged deeper than any immersed tunnel before.
I built that element. I laid that rebar. I pulled that valve. I flooded this thing, and look at it go. Very soon, it's gonna have trains running through it. For the first time, being one of 11 pieces just like this to connect 2 continents.
Right now, the first element is already sitting on the seafloor. Unfortunately, that yellow pier is the only way down. It's aptly named the access shaft.
This is the connection bridge that takes us from the jetty over to the access shaft.
Yes, it is.
So that's it right there. That's the access shaft?
That's the access shaft.
Do you have any advice for someone who's going to be going into one of these for the first time? Because really, I've never been in anything like this before in my life.
Yeah, just relax. It's the best thing you can do.
And element 11, just to be clear, is right below us.
It's right below us, yes.
The access shaft is the entrance to the element down below. Think gigantic straw with stairs.
As I'm going down that, I'm not gonna feel the current, am I?
No, you will not feel any current when you go down.
So this is the hole that goes all the way down to the element.
Yes.
Oh. It's gross. Gross. It's like a... So you're climbing down, you're going down, all around you is water, is pressing on you the whole time. When you finally make it down to the element, you'll be in this concrete tube, basically a marooned submarine. There are atmospheres of pressure, water, wanting to push in and crush the thing inside of you. This is gonna be bad.
It's okay.
Let's do it.
4, thank you.
We're going down, 4.
Okay.
We just got the go-ahead. We're going down. I'm about to walk where most people have never walked, on the seafloor. Let the claustrophobia begin. There goes the sun. You hear that? You hear that noise?
This is where the water is. On the outside of this steel plate.
Thank goodness.
The water is there.
I'm happy it's on the outside. 10 meters, 30 feet.
Hopefully it will stay there.
36 feet below the water.
And now you can see as we go down, the steel structures become stronger and stronger.
Thicker and thicker.
Thicker and thicker, yes.
Oh, I like that.
In case something should happen to the upper part, a ship collides or anything like that, all these bolts will give in and the upper part will disappear.
So the idea is that the tube is actually made up of two solid pieces of steel.
That's correct.
And if a boat were to hit it, it's designed to snap in half.
And it shall snap here, not later down.
And then the people are safely stranded at the bottom of the Bosphorus.
Yes.
Sounds like an awesome fate. So right now, at 96 feet below the water, I'm descending into the element. This is no longer the access shaft. This right here, this what I'm touching, this is the roof of the element, number 11. And right now, we're going into it. So, right now I'm standing on the bottom of the Bosporus Strait.
That's the big moment for both of us. First time for you, first time for me.
We're now at the bottom of the sea. This is it. This element that I'm standing in, this is it. This is sitting like a sunken submarine on the seafloor.
Exactly. So there's only one thick steel plate between you, me, and the water.
Oh man, I wish you hadn't put it that way.
This element already ties the world record for depth, and the next 10 sections to come only get deeper.
Just want to be clear, there's a really big difference between being inside of one of these at a shipyard and being inside of one of these on the floor of the Bosporus Strait. What is it like to be a part of this project?
But it's so amazing. I mean, to be part of a 146-year-old dream and then help Turkey to make it true, it's so nice. You can't get a better job than what I have. But this is what engineering is all about, isn't it? You can see that a result comes out of your daily work. It's not only paperwork, it's not only drawings. It's concrete, it's steel, it's a little bit dirty, it's water. That's what we like.
Walking down here, I now see the true beauty of this design. It's not about how it looks, but rather how the incredible way engineering and design come together to conquer the obstacles of underwater construction, bringing two continents much closer together.
I mean, it's really amazing. It's unbelievable. Can we get out of here, please?
Yes, this way, please.